Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. A machine consists of two components. The lifetimes of the two components are identically distributed with the following common density function. F sub x of x equals 3/4 e to the minus 3x plus 3/2 e to the minus 2x for x greater than 0 and 0 otherwise. The machine breaks down if any of the two components fails. Find the expected lifetime of the device. The density can be written as f sub x of x equal to 1/4 times 3 times e to the minus 3x plus 3/4 times 2 e to the minus 2x, and therefore this is a mixed distribution with a weight of 0.25 and an exponential distribution with hazard rate 3 and a weight of 0.75 in an exponential distribution with hazard rate 2. The survival function of this distribution is an analogous mixture of the survival functions of the two exponential distributions, so it is equal to s sub x of x is equal to 1/4 e to the minus 3x plus 3/4 e to the minus 2x, because the survival function for the exponential distribution with hazard rate 3 is e to the minus 3x, and for the one with hazard rate 2, that's e to the minus 2x. Let x1 be the lifetime of the first component, x2 be the lifetime of the second component, and let y be the lifetime of the device. Then y is equal to the minimum of x1 and x2 because the device breaks down if any of the components breaks down. And therefore, the survival function of y, which is the property that y is greater than y, is the property that the minimum of x1 and x2 is greater than y. But for the minimum to be greater than y, well, that's equivalent to both of them being greater than y. And so this is the probability that x1 is greater than y and x2 is greater than y. And because they're independent, that's just the probability that x1 is greater than y times the probability that x2 is greater than y, which is the survival function of this distribution x evaluated at y squared. So it's 1/4 e to the minus 3y plus 3/4 e to the minus 2y, the whole expression squared. And then using the Darth-Vader rule, we calculate that the expected value of y is the integral from 0 to plus infinity of 1/4 e to the minus 3y plus 3/4 e to the minus 2y, the whole expression squared, dy. That's equal to the integral from 0 to plus infinity of 1/16 of e to the minus 6y plus 9/16 e to the minus 4y plus 6/16 e to the minus 5y. But of course, the first expression is, actually this can be written as a sum of three integrals, and then the first integral would be 1/16 times the integral from 0 to plus infinity of e to the minus 6y. That's the integral of a survival function of an exponential distribution with mean 1/6, so the answer, the value of that integral is 1/6. Same way, the integral of e to the minus 4y dy is 1/4, and the integral from 0 to plus infinity of e to the minus 5y dy is 1/5. And therefore, this is 1/16 times 1/6 plus 9/16 times 1/4 plus 6/16 times 1/5, and that's approximately equal to 0.2260, which is answer B. Please remember, this is copyrighted material. The problem itself was written by me, and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.